Now in this video we will discuss about the unbalanced problems. In the last videos we discussed about the balanced transportation problems. Now going to unbalanced transportation problem. So what is meant by unbalanced transportation problem? Unbalanced transportation problem is nothing but the total supply is not equal to demand. That cases is called unbalanced transportation problems. So this is the question they have given. Solve the problem by using the least cost cell method. So only the single step, only the first step is different from both balanced and unbalanced. The remaining process is similar. So check for total supply. Total supply is 15 plus 24 plus 21 plus 42, that is 102, and total demand is 6 plus 27 plus 54. Here the both values are not equal. Total supply is not equal to demand. This problem is called unbalanced transportation problem. How can you solve the unbalanced transportation problem? Check where there is a less value. The total demand is only 87 and total demand is 102. If you add 15 plus 87, it gives 102. Then add additional column in demand. So here add the additional column with values 0, 0, 0, 0 and the less value, that is 15. We have to add here. So now check for balanced condition. Here the total supply is equal to the total demand, that is 102. Now the problem becomes a balanced transportation problem. Continue the problem as in case yes of balanced transportation problem. The process is same. Here among the table select the least cost value. Here 0 is the least cost. We can select this 0, this 0, this 0 or this 0. We can select any 0. I am selecting this 0. So minimum of here minimum of 15 and 15. Here a minimum of 15 and 15 is 15. So write 15 here and cancel the column and cancel the row, because both there is a 15. So cancel both row and column. Here see I am cancel both row and column. Next again the least cost. Here the least cost is 2 times. Here the 2 is 2 times. So in this case either we can select this value or this value, but to get the optimum solution we have to select the cell with which give maximum allotment. Suppose if you select 2 here, my minimum of 6 and 42 is 6. Here we will assign 6, and among 2 and 20 here if you select the 2, minimum of 54 and 24 is 24. Among 6 and 24, which one is the maximum allotment? 24 is the maximum allotment. So I am selecting this 2. So if in any problem, if you get repeated values, solve by this method only. Select the value which gives select the cell which gives the maximum allotments. I am selecting the 24 here. So I am selecting 24 here. So subtract 24 here, and from 24 cancel that row. Next again select the least cost. Least cost is 2. Minimum of 6 and 42. 6. Assign 6 here and cancel the column. Continue the process by selecting the least cost in the cell. 4 I am selecting 4. Minimum of 30 and 36 is 30. Assigning 30 here and cancel the row, column. Next again 8 and 12. 8 is the minimum. Select 27 and 21. Assign the 21 here. Cancel the row. And next 12 is the left only cell, assigning 6 and 6. Here assign the 6 and cancel the row and column. So next draw the allotment table. This is the allotment table. Now the total allotments is 1, 2, 3, 4, 5, 6, and m plus n minus 1 is 4 rows and 4 columns minus 1, that is 7. 8 minus 1, 7. So here the m plus n minus 1 not equal to number of allotments, so we will get the degeneracy. We have to remove the degeneracy. So to remove the degeneracy we have to select a least cell. First the least cell is here the 0. We can select this 0, this 0 or this 0. Any 0 you can select. I am selecting this 0 and allocate this as epsilon. So we are increasing the allotment. Now m plus n minus 1 is equal to number of allotments. But here the condition is that if you are selecting a cell, that will form a open loop, not a closed loop. So open loop means starting here and it will turn at every allocation. Here the allocation is there and it will turn here, again it will turn here, again it can turn here, or direct straight move straight forwards. Here the open loop is formed. So the I am taking the point at the correct place. So number of allocations is equal to m plus n minus 1. This step is only done in order to remove the degeneracy. Suppose if in the problem they will give optimization problem, or directly they will give a problem for 14 marks, we can solve by using UV method or MODI method. UV method ne MODI method and కూడా అంటారు, MODI method. So every problem you have to do this UV method. So this step is only for to remove the degeneracy. So again go to step 3. You have to calculate the UV values. U plus V equal to Cij. Ui plus Vj equal to Cij. Here U1, U2, U3, U4, V1, V2, V3, V4. Always U1 is 0. Go to allocated cell. U1 plus V4 equal to 0. So again V4 is 0. Next here we get obtain the V4. Now go in this, see the allocated cell. Here epsilon is the allocated cell. So U3 plus V4 equal to 0. So U3 also 0. Next here this is the allocated cell. U3 plus V2 equal to 8. So V2 equal to 8 because U3 is 0. Next this is the allocated cell. U4 plus V2 that equal to 8. Sorry 12. 12 means we will get U4 equal to 4. Calculate for all the allocated cell, not for non-allocated cell. Calculate only for allocated cell. Here I did the step-by-step process here, how those values get, how those values are got. Here again the step 4. Step 4 is Pij equal to Ui plus Vj minus Cij. Here the condition is you have to stop the iteration only when all the Pij values is less than or equal to 0. No positive value will be entertained here. So again see C11. This process is only did for non-allocated cells. Okay, here the non-allocated cell is C11. C11 is Ui 0, minus 2, minus 4. Okay, here 4, but our formula is Ui plus Vj minus Cij. This value is the Cij. 0, minus 2, minus 4. See here 6. Did for, we have to do this process for all the non-allocated cell. So I have done here. So I got 3 positive values, but the positive values are not entertained here. So we have to go for another iteration. Another iteration is, so select C22. C22 is the 4, C24 is 2, C44 is 4. Select the maximum value. Here the maximum value is 4. By selecting that cell you have to form a closed loop. So here 4 is C22. C22 is this cell. I kept a dot here because the loop will start here. I am trying to form a closed loop, but the closed loop is not forming by selecting C22. Again I select C44. C44 is this. By using this cell starting here, I am trying to select create a open loop, but the closed loop is not forming here. C22 and C44 we cannot form a closed loop. Next select next value, that is C24. The positive value is 2. Here the positive value is 2. Select this cell C24. C24 is here. So trying to form a closed loop. The loop will start here. We are moving this way, okay, or this way. The closed loop is formed. Starting of the loop will be indicated as positive, next minus, next positive, minus, positive, negative. Okay, now among all the negative sign indicated here, select the least value assigned. Here the least value assigned is negative 24, negative epsilon, negative 6. The least value assigned is 6 here. So subtract that negative value from minus sign. So we have to separate here, here and here, and add that value to positive sign. Here we have to add 6, here we have to add 6, here we have to add 6. So the new table will become here like this. Next again calculate U values, V values, and number of allocations m plus n minus 1 is equal to 7. U values, V values we have to calculate, and again the same procedure. Pij equal to C ui plus Vj minus Cij. That value should be less than or equal to 0. So I am calculating. Again I get the positive values. Again I got the positive values. Next again I am starting the loop by selecting C22. The closed loop will form plus minus. Again I am selecting the least among the negative sign. Here the least is 6. Again the new table will appear like this. Again I calculated Pij, u values, v values. I again calculate, and I again calculate Pij equal to ui plus Vj minus Cij. Here I got all the negative values, so I can stop the process here and I calculate the total cost. Total cost can be calculated as 15 into 0, 6 into 6, 18 into 2, 21 into 8, 6 into 2, 36 into 4. We have to add all these values, but we have to exclude epsilon plus epsilon because we don't know the epsilon value. Okay, so the total cost obtained is 396. Okay, the cost is reduced as compared to previous total transportation cost. So if they asked for optimization case, we have to follow all the procedures, all this procedure. Okay, thank you.